So once again, welcome to the second lecture. Today we start a set of lecture with many different examples of machine learning. We start with regression problems and data types today. Next lectures we will cover topics like classification and segmentation, and after that I'll just simply provide you with some theoretical basics of machine learning. I intentionally do it in that way because I guess for you it will be much easier to understand topics on machine learning when you first see some examples and later on simply get some fundamental theoretical things which are behind. But still, whenever you have any questions during this lecture, just don't hesitate to interrupt me. I can't see your faces, so I cannot interact with you, and it makes it difficult to me to identify the moments I'm just simply speaking. You'd like to raise your hands or ask some questions, so just please feel free to ask me any questions or make some comments during my presentation, okay? So I will start, maybe coming back to our previous lecture, maybe you have some comments, questions concerning our previous lecture. Okay, if not, let's continue. So I will share my screen now. I hope you can see my screen at the moment, don't you? Do you? Yep, you should have. Can you see my screen?
Yes.
Thank you very much. Sometimes I'll just simply ask you this technical question because sometimes it happens that I think that you can see it, but you don't. Okay, so once again, when you look at the course structure, we start with machine learning applications and then go to machine learning algorithms, okay? So in this folder, we have examples of regression problems, classification problem, and segmentation problems. I'll repeat it many times, but regression and classification are both prediction problems, and segmentation is just advanced data analytics approach. Regression is the art of prediction of numerical variable. Classification is the art of prediction of categorical variable. About these data types, we're going to talk a bit more at the end of today's lecture. But just to start with something, my first questions to you is, when you think about the intelligence, what does intelligence mean to you? What does it mean that someone is more intelligent than the other? How would you define that? I'm talking about your personal inspirations. I'm not asking you for any formal psychological definition. I'm not the psychologist, so I'm just simply like to share my insights with you. So, any ideas?
Well, I think that intelligence can be described as ability to receive signals, read them correctly, and adjust correctly to the signals, to act accordingly to different signals. Well,
Okay, so
if we talk with people, then different messages, well, different topics require different response.
Okay, so it's about the communication and properly understanding the intention of someone who communicates something to you. Yes, am I right?
Yes, I would say so.
Because if you just put it directly, what you said, CCTV camera which follows you, yes, automatically would be intelligent because that camera correctly adopts to the signal, yeah? But you mean something more, so I think
that was just an example.
Yep.
More broadly, I would extend it to ability to adapt to the environment, like to different forms of inputs.
Adaptation. Yeah, it's very close to mine. Yes, it's very close to mine. I have a bit different, but I will share it with you later on. Maybe some other approaches. What does the intelligence mean to you? If you imagine a very smart, intelligent person around you, what does it mean that you think? Why do you think it's intelligent?
Being able to share a valuable opinion, but then also respect others' opinions too.
Aha, so I understand. So this person reads the environment, makes some insights, and then is capable to share this insight in a not only correct but also polite way. Am I right? Respect to others, yes?
Yeah.
Yeah, very good. Some other ideas? Obviously, there are no good, bad answers here. I'm just simply testing your feelings about the intelligence. Okay, so let me share with you my own working definition of intelligence, because each year it changes a little bit. For me, intelligence stands for the ability to efficiently behave in the new situation. So it's a close to adaptation, yes. So, but when you decompose this statement, so what do we have? We have efficiently behave. So we need to have some goal function, yes, very precisely defined. So, for example, when you are looking for the best way from point A, from the city A to the city B, yes, and we are looking for the applications like Google Maps, that means that you need to have this the best defined, because for someone, when you where you look for the road, apologies, sometimes it means that it's the shortest in the geographical distance, but sometimes means it's the fastest, yes, or sometimes means that it's the most ecological. Yeah, so this is a very good layer at the moment in Google Maps, which it shows you the CO2 consumption. Yes, sometimes it means the most beautiful. Yeah, so depending on your goal function, yes, this the best will change. So efficiently behave. So efficiently. Next, behave. It's not that easy. It seems to be trivial, but it's not. Imagine that you have a robot, yes? A robot in the industry or just simply on the moon, whatever. If you were to program such a robot, you encounter the difference between the agent, which is a software which makes decisions, autonomous decisions basing on the signals from the environment, and its arms, or all the micro engines which move the body, I would call it, of the robot. Yes, so the agent is a software which makes decision. Yes, but all its body, all the arms are elements of its environment. So ability to behave means that you do not only make the decision, but you are also capable to execute this decision. Yes, this is very, very strong assumption sometimes. So efficiently behave. But the key word here in my definition is a new situation. So when you have someone or something, yeah, which makes good decisions or behaves efficiently in the environment which was already present in the past as a learning example, that means that you are programmed. Yes, so you were taught to behave in such a situation, do this. So if this, then that. Yes, but in case there is something new happening, completely new situation, if you are not intelligent, you completely lose the control. Yes, so you cannot behave. In psychology, this mechanism of generalization is called the transfer. So this intelligence means the ability to transfer the knowledge you acquire during the training process to completely new situations. Okay, so once again, that's my best definition. You can obviously confront it with yours, or do whatever with you. And I started this. I have a bit more elaboration on this topic in one of my books. This is the book here, AI in Business, the second one from 2020. So if you'd like to read a chapter on this, it's one of the first chapters. The first chapter is, by the way, devoted to reinforcement learning, which forms the basis for autonomous systems. Okay, let's come back. And this makes a background context for our first example, which seems to be trivial, but in fact is not. I'll show you something. Let's have a look at this data. Let's have a look at this data, those data points. Can you see something in this data, in these two columns? Just have a look, think about them. What can you see? Can you see any pattern or something? Okay, so what would you do just to see the pattern?
Graph it in Excel, since we're already there.
So this is the Excel. So what would you do?
Graph it with one of the columns as X, the other as Y, and
yeah. So just simply insert plot, yeah. So now, can you see something?
Yeah, it's close to linear.
Yeah, it's close to linear. Sometimes people can see the line, but there's no line here. If you can see the line here, that means that you hallucinate because there is no line. But now you can see quite easily kind of the pattern, yes, almost linear relation. And how do you think why it was that difficult for you to see the pattern in numbers, but now when you visualize, the only thing I changed was the way we represent data, yes? So why it was much easier and faster for you to see the pattern on the plot compared to the set of numbers? Did you think about this?
The data was not ordered?
Nope. There is no order on the plot also. They are just simply points.
Yeah, it is like we have the x-axis and the y-axis in a way. So it introduces some order that's not there in the columns.
Yep. Yes, you are right. That's you are right. Okay, but some other reasons? Okay, I will tell you. It's pure neurological historical reason. When we have something plotted, we can use our visual cortex, which is much older, much stronger. Our graphic card as a part of the brain is much stronger than analytical part of the for brain, which is much younger. For us as animals, it was much more important to very fastly identify a poor friend in the forest using our eyes than to, for example, compute some complicated integral in Banach space, yes, using just simply computation. Okay, but still, that's another story. Okay, but let's continue. Now what I'm gonna do, I will just simply add a trend line, this, and I'll also supplement this with the equation, yeah, equation. Yep. And now I will try to defend the statement that this line with this equation, yes, this equation, y equals to 79.9 times x. Apologies for this. I'm just really trying to make it larger. No, it won't work. I claim that this is artificial intelligence. And now, what do you think about this statement? As I said, that seems to be trivial, but it's not. This example, if you catch it now, it will be much easier for you to follow up with next lectures, which will be a bit more complicated. An idea? Okay, so I'll help you. My idea of the intelligence is the ability to efficiently behave in a new situation. In which sense, the straight line with this equation represents the ability to efficiently behave in a new situation.
Calculating each point.
Yeah. Yes, almost right. So I'll give you another example just to make it more touchable, I would say, more realistic for you. Imagine that we have a company that's going to be our next example, by the way, which buys and sells flats, houses in Warsaw. Okay, and each data point is a flat. Okay, here on the x-axis we have the surface in square meters or square foot, whatever you choose. And on the vertical axis, y-axis, we have the price. Yes? Forget about those negative numbers. It's not important at the moment. So each point is flat. So for example, this is, let's say, 30 square meters flat sold for 250,000 Polish złotych. Okay, this is 45 square meter flat. And this is sold for 350,000 Polish złotych, etc., etc., etc. Yep. And we have 15 different flats sold. And now we'd like to have a model, like to create a model, which for a new flat, which comes to our offer, for example, a lady comes with the flat saying, okay, I have a flat which surface is 73 square meters, yes, 73, let's say it's somewhere here. And we didn't have such flat previously in our experience because we had something for 69 and we had some for 78, but we didn't have any flat with 73. This model still helps us predict the price for this, yes? Although it was not present in the past, we can efficiently behave in a new situation, and this new situation is defined as a new example in our data set. New in the sense that it's a flat with some completely new surface, yes, but we can still estimate the sales price. Do you catch it now? Is it clear?
Yes.
Okay, so this is the simplest possible, but still, this is artificial in the sense that this curve was created by the machine, by Excel spreadsheet, using some algorithm, like, for example, we're going to talk about these algorithms later on, ridge regression, or linear regression, whatever, yes? And this is intelligence because it helps us to behave efficiently in a new situation. Okay, so let's continue with this example. And we'll go into a bit more advanced case. In each of the folders I shared with you, once again, on my first presentation, I provided you with the hyperlink to my Google Drive. Moreover, those examples are also on our Microsoft Teams, so you have the access to all those data sets. Each example is supplemented with the README file. In this README, you have the information about the problem. You have the data source, like this is taken from Kaggle. Kaggle, once again, is a place with dozens of hundreds of different competitions on data science, the most advanced place for this. In our case, this data set represents the more than 1,400 different flats sold in US. And here you can see 80 different features of such a flat. This is a sales flat, but also you have many different other features. Some of them are categorical, some are numerical. In all of those descriptions, you have also some extra simple tasks. If you'd like to follow this example and solve it by yourself in a bit more advanced way, you can do it using those data sets and the Tateco platform. So let's come back to our example. Okay, so we are going to try to predict the price of the house from this data set. So in order to do this, I will use Dataeco platform. So once again, I'll just simply make some order on my computer. You have probably received the access to this platform. This is the data science platform, one of the best platforms in the world. I'm not a reseller, so have no business relations with them. I'm just simply showing this platform to you because this is the easiest, in my personal opinion, possible way to interact with the machine learning. So to create machine learning model without coding, interpret this model without advanced statistics knowledge. So no Python involved, although you can inject Python in the project if you want, or you can escape with the Python from the project itself. And obviously there are plenty of tools like this. So my goal is not to teach you Dataeco, but to use the Dataeco as a tool to help you understand machine learning. All those examples are possible to be done in Python if you want, but in case we work in Python, it would take us much more time to see some things and to follow up simply those fascinating but still difficult topics. Okay, so that was the explanation. And once again, plenty different types of those platforms. I choose this one because I like it. There are many reasons why I choose this. Okay, so I create a new project, a blank project. I will call it International. Okay. The first step I'm doing in such a project is just importing the data set. We're going to talk a bit more about the different data types later on. Now I'd like to focus on the very simple example. So let me now drag and drop this first data set to Dataeco. Oh, apologies for this. Once again. It's not like this. So I'm gonna do this. I need to click here and now. Okay, so, oh, Jesus. Apologies for this. I simply have some problems with interaction. Okay. Hamza, okay. So drag and drop. So I create the first data set. And what do we have here? We have more than 1,400 flats. Each row represents the salt flat. At the moment, we have one single variable, which is the surface of the flat. Yes, you can see the description of this variable is in my README file. But this is just as a basement surface. And as humans who live in the cities or somewhere else, we have such an approach that, okay, the price of the flat is mostly determined by its surface. Yes, so let's check it out. Firstly, graphically, okay, so just simply put on the y-axis the sales price, on the x-axis the total basement surface, and can see the picture showing that there is a kind of the correlation, can you see, between the price and the basement. So this is like we expected. Okay, the larger flat, the larger size, the larger the price. So having this, and it corresponds to our previous example from Excel spreadsheet, okay, we can create a kind of the model which for a new flat will help us predict its price. Okay, so let's do it. Let's do it. That's gonna be the first machine learning model, the second machine learning model trained, because this first one was this in an Excel spreadsheet. Yes, this regression line was just a machine learning system. Okay, so what I do, it's being recorded. So if you'd like to follow up later on at home with me, so you can still open the course and check the recording. So let's go to lab now. We have many different options. We are going to use AutoML prediction. AutoML stands for automated machine learning. So the system will do everything for us. It will choose the proper algorithm. It will make a feature engineering. It will perform the training. It will evaluate the model, compare different models, blah, blah, blah. So that's automated machine learning. If you want, you can train deep neural networks. You can make the clustering, not the prediction, yes. Time series forecasting, object detection using deep neural networks, so image classification, many different problems, or just perform some visual analysis. Okay, let's do AutoML prediction. This is the first shot. System asks us, okay, what the feature you would like to predict? I want to predict the sales price. That means I ask the system to create the model, which for a new flat, which I do not know the price, it will inject as a question the total surface and will give me the answer as a price. So let's train the model. I click create. Train the model. The system has chosen 2 different algorithms to train. So now we train the model. And here we are. It has chosen 2 algorithms. First one was L2 regression. Second one was just random forest. As we can see, the winner is random forest. How do we identify the winner? We have some measure of the regression problem quality. At the moment, this measure is here. This is the metric. Metric is R2 score. We're going to talk about this later on. Very popular measure, helping us to identify the quality, to detect the quality of the model. If you drill down here, you'll have many different measures. The most popular are RMSE, which is the root mean square error of the prediction compared to the reality. We are going to use MAPE, which stands for mean average percentage error. We are going to have a separate lecture on evaluation of the model, so don't worry if you can't follow. The explanation is very simple. If we have 26% here, that means that on average, our model makes 26% error predicting the price of the flat basing on the surface. So here comes the first question. If you were the owner of the company which orders such a model from the data science team and you pay some money for this model, okay, would you be happy with that value or not?
Not really.
Not really, yeah. So I think that my employee would do it better even. Yes. 26%, come on, it's a quarter of the value. So the question now is how to improve the quality. What would you do? How to get better model which will predict it better.
And maybe train it on bigger data.
In more data, yes, or another data. Okay, and that's what we are going to do. Precisely speaking, we are not going to test it, train it on another data, but we will make a feature enrichment. We'll just simply take into account more features. Okay, so let's do it. Do you remember? Just put it somewhere. Try to remember 26% error in case we take only one variable into account. Yes. So now let's add some extra variables. So I upload another data set. At the moment, that's Ames housing full data set. Drag and drop. What do we have here? We have once again the same number of rows, 1,460 rows. But at the moment, I have 81 columns in my data set. 81 columns. And the ID is 1 column, it has no value. Okay, the price, sales price is another. So if you subtract 81 from 81.2, that's gonna give us 79 features. In our previous data set, we have only one feature that was just a surface, yes? Now we have 79, much more features, yes? The second important fact for you is that these features are both numerical, like here, numbers, but also categorical. There are some labels, yes, describing the flat or its neighborhood, yeah. So compared to the Excel example we did at the very beginning of this lecture, in the Excel example we simply had the explained variable, which was the something we would like to predict, which is the sales price, and the feature, which was the square foot. So it was easy for us to plot this, firstly, because both were numerical, and secondly, there was only one feature, so it's possible to plot two features on the two-dimensional surface, and then to, for example, even visually identify the correlation, yes? But in case we have 3 dimensions, so 2 features and 1 explained variable, yes, we can still see some pattern in 3 dimensions. 4 dimensions is much more difficult because we would have to use either the color or some animation, but forget about 5 or more. Now we have 79. Moreover, in that case, we have plenty of categorical variables. So for sure, this approach we used previously, either visual or linear regression, traditional linear regression won't work, but still, in our machine learning system, we can still train the model. I go to lab, I go to AutoML prediction. It's trivial. I just simply click sales price, create a model for the sales price prediction, create the model, and train it. I will change it to MAPE. That's my favorite measure for this. And what's the result? How do you like it now?
Better.
Better, yep. So adding extra features improves the quality of our prediction model from 26 to 11. Yes, so it's a huge improvement. And it's still manageable, but we wouldn't do this by hand using the Excel spreadsheet. Yes, so that's why we benefit. This is how we benefit from machine learning. Okay. Any questions till now? Maybe some comments, reflections? Okay, so let's continue to a bit more advanced case. But maybe before, I'll just simply drill down into the model itself. So what I did, once again, I just simply identified the random forest as the winner. I rolled over this hyperlink and clicked, and I can see the model card. I can see predicted data, so I can see them on chart if I want. I have a lot of different stuff here, but the most important here is the structure for you. You have explainability section when you can see decision trees if it's a decision based model, variable importance, and some error distribution, metric assertions, and model information. And now let's spend a second on this part. This is variable importance. How can you use this value? How can you use? Okay, I will tell you. How is it computed? How variable importance is generally computed both in regression and classification problems. Once again, we have some features. These are the features, yes, and we have some variable we'd like to predict the sales price in our case. And we create some model. So naturally, some variables are more important to the model quality or less. And this is the key sentence I told you. Well, more or less important to the model quality. How do we compute these measures? We simply, in the background, train dozens of different models. For each new model we train, we simply subtract a given feature from the feature set and check how the subtraction of the given feature impacts the model quality. Yes, I will show it to you later on. And I get the following information. What's the most important feature for the price? How do you think? If you look at the name of the feature.
Overall quality?
Yes, overall quality. Okay, how clean is it? Whether it's modernized or not. Next, gross living area. And then finally, as the fifth feature, we started with this total basement surface. Yes? So how can you use this information? If you were the flat owner or the company which resells flats, what type of actions you could do based on this insight?
Like invest in places that have high overall quality.
Or some other idea, very, very close. Okay, I will tell you, because now I will just simply give you some meta view of the problem. From the data science perspective, if you go to the sponsor or the investor, yes, or to your CEO, Chief Executive Officer, you would say, okay, I have a model which with the 11% accuracy, I would say, okay, it's in fact not accuracy because accuracy is used for classification, okay, but the model which with 11% accuracy will predict the price of the flat. Yes, so this is your message to the owner. But the owner or investor, it's not enough for him, okay? The knowledge in business is valuable almost only if it's actionable. Okay, so the question is, okay, you have the model which with the accuracy of 11% is going to predict the price of the model, and my question is, so what? What can you do with this? Yes, what would you say as someone who would like to sell this model to the company? What can you do? What type of actions you can make having such a predictive model with that quality? Think a second. This is the very important question. Okay, so imagine you are the owner of such a company which buys and sells flats in Warsaw, okay? Before the model, each time someone comes to you, yes, you had to ask yourself, based on your own intuition, based on your own experiences, what would be the market price, yes, for a given flat? Because someone comes to you and says, okay, I would like to sell this flat for you for that amount of money, okay? And then you need to think whether this offer is interesting to you or not. In other ways, is it possible for you to resell this flat later on for a higher price? Yes. So before you you had to base on your intuition. And what's the added value of this model to you as the business owner?
We can justify the price looking at the like characteristics.
Very good. So probably this prediction first is gonna be automatic. Yes. So it's cheaper and faster. Yes. Probably it may happen that will be better in the price prediction than your own experience. Yes. And what type of decision you could make basing on this forecast? For example, someone comes to you and says, okay, I have a flat in that neighborhood, in that quarter in Warsaw, and it has, let's say, 95 square meters, and I would like to sell it for you for 1.2 million Polish zlotych, okay? And now you use the model, and what's the added value? What type of the decision you could make based on this? This is a very important discussion.
We can ask what's the overall quality of life in that area.
Okay, I would do another thing. I will ask the model, okay, someone gives me this flat, okay, and the price it asks is 1.2 million zlotych, okay, and now the model tells me, okay, the market price for this is 0.9, so I just simply quit. I'm not interested. But on opposite, if someone comes to me with that flat and wants to sell it to you for 600,000 Polish zlotych, but it's priced on the market for 900, it's obviously a deal for you, yes? And later on, and now we come back to my first question, we go to the variable importance. Sometimes it may happen that for you as the flat owner, sometimes it's really, really good to invest in renovation of the flat, because renovation of the flat may cost you, let's say, 50,000 Polish zloty, but may increase the market value of the flat for 150,000 Polish zloty. You know what I mean? Because this is the most important factor here. So once again, why do I say to you? It's not statistical elaboration, what I'm just simply showing you, but this is the example of the situation where statistical modeling and model training is just a very, very, very small part of the whole story, which is just using this model later on in the production. Okay, so let's continue. Any questions, comments till now? Or we can continue. Okay, so let's go. So now, next example, very interesting, I think. What do we have here? Let me open the README file for you. This is the case study based on one of the tutorials of Dataiku. Most of my examples are not based on Dataiku, but this one is. And the story is the following. You own or you run the e-commerce store, which globally sells t-shirts online, okay? And you have a data set of your customers. And for each customer, you know the age of a customer, the price of the first item purchased in your store, gender, IP address of the computer, the country which you infer from this IP address. Later on, I'm going to show you how you can do it. Pages visited on average by a given person. On average visit, it visits, for example, 12 different pages, and whether the person joined you from the campaign or not, and then GDP, gross domestic product per capita, of the country she or he lives in. And the final value is the total revenue. This is the variable you would like to forecast. The tricky point here is that this revenue is computed for the customers who are no longer your customers. Okay, so that means that this is the customer lifetime value. Customer lifetime value, this is the amount of money the customer paid for your goods, left in your store, okay, during the whole lifetime, from the first registration to the final transaction, okay, later didn't come back. So that's why we call it customer lifetime value, okay. So this is our story. If you would like to follow, this is the small instruction how to do this. So let's make this modeling in Dataiku. So I just simply create blank project, TLV International. As previously, I import my dataset. Jesus, it's there. I need to minimize this. Okay, I'll just simply minimize it. So I upload the files. I upload existing customers. Create dataset. And as you can see, we have the dataset. We can also check the status. How many rows do we have? I compute the statistics for this. As you can see, we have 23,399 customers in our database. So a lot. For each we have ID, age, price, first item, persons. Then we are ready to predict this variable, which is revenue. Okay. So before we continue, let's once again contemplate the value added of this model. So it's gonna work that way, but basing on this history, these are true real experiences. Yes, the person with that features left that amount of money in my store. Okay, I would like to create a model which, for a new customer for which I do not know the revenue, okay, will quite correctly predict this customer lifetime value. My question before we continue is how it can be used. What's the value for a company from such a model? How you can use it? How do you think?
Target products.
Excuse me?
We can target specific products like customers.
Okay,
like
so
knowing how much they spend.
So what does it mean specific products? Because at the moment I do not know what my model won't tell me what type of the products a given person is interested in. It just simply tell me how much money during the lifetime this person will live in my store. So how would you like to target the product?
Well, basically, okay, so go first.
Yeah? You go first.
Okay, so yeah, so basically we know the countries, we know like the specific IP, so probably we can like extract the current like region of this country, and basically we just know in what regions our product is like popular, so we probably can promote our product to a specific country, to a specific region, and probably to like specific people. For instance, if our product is more popular for, I don't know, a male audience, so basically we should target them. So
not from this problem, because we do not have a list of the products, and the only thing the model will help us to predict is the revenue, which is the customer lifetime value. Okay, so let's leave it. I will show it to you later on. Okay, let's train it. Let's go to lab. Once again, I go to AutoML prediction. Each use case will show you another aspect of machine learning. Okay, that's how I build my story. Okay, in machine learning. So I create quick prototype. I have chosen the revenue as the variable to predict. Then I go create, train the model. Okay, I have it. I have a model with accuracy. Precisely speaking, it's not accuracy, but if you talk to business, you can use this word. Of 7% is capable to predict for a new customer all the money it will live with us during its life cycle, from the first registration to the final contact, final transaction. Okay. An idea how we can use this model in our business? What's that value? You said that, okay, we can target product. I'm not really convinced because I do not know from my data set what type of products a given person likes. The only thing I can do is to infer the potential value of the customer to me. Okay? No idea? Still?
Well, somehow force the customer to perform the first purchase in our store or something like that.
Okay, so now let's go to next step. It will be more clear for you after a few minutes. Okay, so this is once again the model card. I can see the variable importance here. And if you look at this model, what is the most important variable for you? Which has the strongest correlation with the customer lifetime value?
GDP per capita.
Joint GDP. So that means that the most important variable is the country from which this person comes. Yes, from United States versus India, for example. Yes. Next. This is a very interesting variable.
Of the first item.
So this is the price first item purchased. This is a very interesting observation because it tells us that the customer lifetime value is really strongly correlated with the price of the first item purchased by a given person in his history. Okay, so once again, during its lifetime, a given person may have purchased many different items, okay? But the price of the first item it purchased, yes, has the strongest correlation with the customer lifetime value. How can you use this? How can you use this information? An idea?
If the price of the first item is affordable, then they might be more eager to purchase again.
But what type of actions would you do?
Like display the cheapest products, maybe.
But what in case when it's opposite, when you think that, for example, if someone purchases some very highly priced at the very beginning, that means that it will leave a lot of money. You understand my question?
Yeah.
Because you assumed that the lower the price, the higher the customer lifetime value. Okay, but I can also say the opposite. The higher the price, the higher the customer lifetime value. Do you understand?
Yeah, but you can also display depending on the country. So GDP, it's poorer country, cheaper products, and then like a more developed country, more expensive products.
Okay, so now here come two things, very important two things for you. Firstly, and this is another extremely important part of my lecture today. Traditional machine learning models, probably 99% of machine learning models you are going to work with now in your career, during your studies, bases on correlation. Okay, correlation between variables, but correlation does not mean causation. Okay, causation means that there is a root cause relation between the variable A and variable B. maybe we're going to have some lecture on this, but I'm not too sure. If you're interested in this, we can make a lecture on this. I really love that area, but I will give you the example. This is a very famous example of the situation of the plot where you have on the vertical axis number of murder crimes, yes, murders in Mexico, and on x-axis you have the ice cream consumption. And this is a beautiful correlation. You know what I mean? Murders, ice cream. Does it mean that eating ice creams makes people that angry when they kill each other? Or maybe does it mean opposite? Maybe if people kill someone, they love to eat ice cream after that? How do you think?
I think the Mexico is very like hot country and people are fighting for the ice cream there. So that
that may be another option. And we are very, very close to this. In causal relation, this is so-called co-founder. This is an extra variable. That's probably different thing you thought, but this is precisely this. The air temperature, which impacts both ice cream consumption and human temperament, you know, lose of control. The heater the air, the easier you lose the control, okay? So you cannot infer the causal relation between killing people and eating ice cream. Simply they are correlated, but there is some other mechanism behind that, yes? So at the moment, we cannot say that price first item purchased impacts the customer lifetime value. We can only say that it's correlated, okay? And I will give you another example, which is key. This is also very famous. Imagine that you are a decision maker in some, I don't know, country in Poland, and you can see, and I can give you such a scientific papers, a picture which shows the perfect correlation, almost perfect correlation, strong correlation between number of fires in the forest, for example, or buildings, versus number of fire squad teams. You know, the fire squad team, you know, those trucks which simply carry the water to fight fire, okay? And this is a very strong correlation, okay? And I'd like to make a decision basing on this. What should you do? The more cars you have, fire squads, the more fires you have, yes? So just simply decrease the number of them, which is completely stupid. Once again, correlation does not mean the causation. So in machine learning, you play with correlations. So beware of this. And now, what would you do to identify truly the root cause on a relation between two variables? How do you think? How it's manageable? Okay, I will give you a tip. The only way to identify causal relation is to make an experiment, so-called A/B test. A, B means that you split your population into half, A and B, 50-50, randomly. And for A, which is the control group, you do nothing. For B, which is the test group, you test some action. And after some time, you compare the factor you would like to check the impact on, okay? So this is the experiment. And it's very, very costly. It's mostly done by big pharma companies which really need to understand the causal relation between the treatment and the effect. Fortunately, and this is quite modern area of research, the so-called causal machine learning, causal ML system, which helps you to identify causal relations between variables without making experiments, which is, by the way, very exciting and very important area of research nowadays. So if you have some time, if you plan your future, and I strongly suggest you to look at A/B testing in business, not only in UX design, not only user experience design, but also in business, and secondly, causal ML. So take away the fact that you can see those variables Remember how carefully I have chosen my words. I didn't say that joint GDP per capita impacts CLV. I just simply said it's strongly correlated with. Okay, be aware because many analysis I know they simply forget about this slide. But very important difference. And now let's come back. How you can test it? How to test whether the price first item purchased when higher makes higher or lower customer value. We have this tool. Now I click what if analysis. You see? And what I have here, this is the example, prediction for revenue for some person, 178. And as you can see, I have those features here in the order of the importance. And now I can play with this. This is a kind of simulator. So now I can, for example, take this joint GDP per capita and move back the left or forth to the right. How do you think? If I move to the right, so I try to sample the data set looking for persons who come from the richer countries, yes? This prediction for revenue will go higher or lower? How do you guess? Oops, I did it. Apologies, I clicked it. As you can see, the higher, the lower GDP, the lower revenue, okay? This is the simulation. And we can do the same with this price item purchased. You were previously stating that the higher the price, the lower CLV, customer lifetime value. So let's check it. I can click it here. Nope, it's opposite. The higher the price first item purchased, the higher the prediction of the revenue. Can you see it? So this is the kind of the simulator. Very nice thing. It helps you to understand the business. Once again, look, if the higher the age, the higher the customer lifetime value. So this is a very nice tool to simulate the prediction. Why it's nice? Because it helps you to understand your business. Helps you to understand the business, but once again, keep in mind that it's just a correlation. It does not mean the causal relation. Okay? Any questions, comments? Okay. If not, let's continue. Let's continue with another example. Oh, not. Before we continue, I will come back to my original question. Okay. Once again, I need to train it. Apologies for this. I didn't save the training. My original question was, okay, imagine that now you have this model trained and you would like to use it in production. What would be the value for you? What type of decision you could make having the model, which for the existing customer, it will tell you how much money this customer will spend in your store during its lifetime. Okay, what would you do with such a model? How it can help you? What type of decision you could make? Okay, I will help you. I really like to talk to you because if you answer those questions, it will be much easier for you to follow next ideas. Imagine that you have two customers, okay? Well, let's do it. Let's put it into production. So now I'll just simply deploy the model. I told you that the deployment is very, very difficult. So when I drill down into the model, I have different actions. I have export this model. I can export this model in a Java format or in the Python, MLflow. PMML format. So you can literally download the model as a file on the drive and then later on put it to the server if you would like to make a service on this. I have another lecture which is quite advanced on ML DevOps, where I just simply show you how to take those models into production and how to use tools like Docker, Kubernetes, or some cloud service provider platforms like Amazon or Google to take care about this model during its life cycle. Never mind, it's another story. But I can also deploy this model within Dataiku, because Dataiku is a full stack machine learning platform, so it supports you also in deployment. So let's do it. I will deploy this model, and as you can see, I have it deployed now. What you see now is so-called machine learning pipeline, the very easy one. The real are much more complicated. But before we make things complicated, let's start with something simple. A machine learning pipeline is a sequence of actions performed on some artifacts, products, objects. Objects here are displayed in a rectangular format. These are so-called artifacts. These are files. Most cases, for example, this data set is the artifact, and this model is the artifact. Okay, the artifact is an input to so-called component, which in most cases is a kind of the transformation of the artifact. That may be data cleaning, data transformation, or model training, as it is in this case. So these are the products, and components are actions. So this artifact is input to this component, and this component outputs that artifact. Okay? These are in most cases can be saved as files, and these are simply codes, let's say scripts, whatever. Okay, so now I will add an extra artifact. I add a new customers file. Just look closely at this data set. How does it differ from our training data set? How do you think? Can you see the difference?
There's no revenue.
No revenue. And why? How do you think? Why do we don't have a revenue now?
Because they're new customers.
Yes, precisely speaking, we are touching now the essence of machine learning. Look, I will show you on some simple presentation we had a week ago. I'll show you how it works. I'll show it to you on one slide. This is the slide. During the first stage, the training stage, we had some training data which had features of the customers and then the label we wanted to predict, which was the revenue. Yes? We asked many different models like ridge regression, random forest, and many more to identify patterns. And then we saved this model as this rectangle artifact on the production. Okay? And now we come to the inference stage. We have this model because we would like to know the revenue for the customers which are new to us. Okay, we do not know the revenue. Okay, so now I will just simply take this question. This is this new customers data set. It has all the features of the customers, but we miss revenue. I put it into the model, and I expect this model to generate an extra column, which is going to be predicted revenue. Okay, so that's the idea. In this training data set, I need to have both features and the explained variable. This is the question, and these are the answers I learn. And later on, I learn it just for this, to be capable to answer the question, which is the set of customers without the known answer. So this is the reason why I have no revenue feature here. So now let's apply this. So I have this predict revenue regression model, okay. And now I open the panel and apply model on data to predict. So I click this core button. I choose the input data set. I choose new customers here and create recipe. Very good. So I run the code. Super. And now let's have a look at the flow. This is our pipeline now. Look what happened. That was the first training stage. I took the training data set, made the training, and got the model. Yes, this is this brain from my PowerPoint. Yes. Next, I took this set of new customers, which we didn't have this revenue column, put it through the inference stage. This is the inference stage, which takes as input also the model into inference component. Yes. So this is the model, this is the question, and I get the answer. New customers scored. And now, as you can see, I can see this prediction. So this model tells me, okay, you have a new customer, just at the age of 66. The first purchase was on 22, let's say US dollars. This is women living in Germany, okay? It has already visited 3 pages, didn't came from the campaign. And in Germany, we have this amount of US dollars per capita. So we predict that this customer will leave 158 US dollars in the store, okay? So now you can see the inference. We did a training, we did the inference, deployed the model. And now the question is, what's the value of this prediction for you? This is the key question. What type of decision? Yes?
Could you repeat the question? I didn't hear.
Once again, I can't hear you.
Could you repeat? I didn't hear the question.
Okay, I repeat once again. So we imagine that you have, let's say, 2 customers, this one and this one, okay? You do not know how much money they will spend in your store, okay? And imagine now that you have for this customer prediction of, let's keep those 2. These are 2. Very good, okay? The system tells you that the customer, this which is highlighted in green at the moment, during its life cycle, we leave $160 in your store, and this one will leave $104. What type of decision would you make based on this information, based on this prediction?
That we would rather get the 160 than 104.
What would you do?
We would rather get the customer who spends more.
But what does it mean get? It is already your customer, yes? So this is your existing customer. It's new in that sense that it had made just a few purchases, but some other ideas? Keep. So take care about, yes? You're right. Am I right?
Yes.
Oh, very good. It's a very tricky question. Once upon a time, I have found very interesting suggestion of actions concerning those 2. Obviously, it's very tempting to treat this person as more valuable than this one and take care about this and forget about this, yes? It's very tempting, especially, for example, here, 148, 143, yes? or 148 versus, for example, this one. But let's stay here. But the real number you'd like to know is the customer potential, which is the difference between the customer lifetime prediction, which for this person is 248, and for this for 143, and subtract from this number the total volume of purchases of a given person, because that gives you the potential. And now example. Imagine that this person has already purchased in your store for $220. Yes? So the potential of the purchase of this person is 248 minus 220, which means 28. Yes? And this person has the predicted customer lifetime value of 143, but has already purchased for $40. So its potential is $103, $100. You have $28 here and $103 here. So from that point of view, this customer has a higher potential for you. Okay. So as you can see, once again, we may have many different actions following the prediction based on the model, and this part of the machine learning process or data science process, this design of the actions is key for the success of your project. I'm pretty aware that it may be not interesting for the engineer, but believe me, in case you come to the real project in your future, that type of considerations will be extremely critical. It will be critical for you when it comes to, for example, model optimization, model training, model interpretation, and etc., etc. Okay? Any questions, comments? Good. So if not, let's change the topic. We have 12 minutes left. So this is a perfect time now for a bit more theoretical lecture, but very important. On the next lecture, I will tell you another examples for classification and segmentation, but now let's talk about data types and visualization, okay? The key point here is to explain you the importance of the distinction between numerical variables and categorical variables. As you will see, this is important for two things you'll see in the future, let's say 10 minutes from now. First thing, it's key for plotting the data visualization in business intelligence. And secondly, that forms the basis for the type of the machine learning problem. So let's start. Numerical variables are quantitative data attributes. As you can see on this spreadsheet, Google spreadsheet here, when we have the sales of goods in a given branch, A, B, C stand for a location of the store, and total stands for the total volume of the goods sold. Yes, this is the number, total is a number, because it's a numerical, this is the numerical variable because it's measured. Okay, so whenever you have any measurement, whenever you ask how many, how long, whatever, that means that the number. For those numbers, for those numerical measures, you can compute aggregations. You can aggregate to a single number. Like, for example, here we have 25 rows, yes, and we can aggregate those rows into one number like average. So I take the average of those 25 numbers is 36.48. Yes, or I can compute another single number which is median. It's another aggregate. Or I can sum them. So once again, this is single number. This aggregate is called metrics. Okay, we have many different metrics like number, total, which is sum, mean, median, mode, standard deviation, min, max, whatever. Okay, so you can compute something like this for numerical variables. Numerical variables, if you would like to, and we have the examples of numerical variables are product, price, duration, number of transactions, length, width, volume, weight, etc. Can be broken down by dimensions. Dimensions are categorical variables. They provide the context for numerical measures. These are qualitative, descriptive data attributes, so-called categorical data, and the example here is the branch name. I just simply took the simple name here, ABC, and as you can see, it's impossible to compute a mean or total sum, or standard deviation for this. You cannot compute this, yes, because these are names, the categorical variables, qualitative data attributes. The only thing we can do is to compute the number of occurrences of objects with the given value of categorical variable. Like we have, for example, 13 or 14 branches with A name, or purchases in the name branch A. Let's say 7 purchases for brand B and 4 purchases in brand C. Yes. Categorical variables help you understand and organize quantitative data. They can also help you determine the level of detail in reports, like, for example, may have sales by region or sub-regions, sales by year, quarter, month, week. So these are simply extra variables. Okay. Till now, it seems to be very clear and almost trivial, but it's not trivial if you firstly recognize that sometimes categorical variables are represented by numbers. Can you give me some example of the categorical variable which is represented by a number? Okay, I will give you. The example is your personal ID, which is in most cases the number. Yep. It's not the effect of measurement. It's just a stamp. Yeah, this is the label. Or, for example, sometimes when you have the machine learning model which predicts whether the customer will churn or not, the category is described either 0 for non-churn or 1. 0 stands for no, 1 stands for yes. But still they are presented as numbers, being a categorical variables, yes? And as you will see later on, misleading those two things may be tragicomical in consequences. Okay, and now another aspect. We have three different types of dimensions, categorical variables. Nominal dimensions, these are usual names, labels, and that's what we're used to. Like, for example, this is a man, this is women, yes, this is a cat, dog, or tree, computer, whatever, just a simple name. Next, we have some order dimensions. The elements can be ordered like agree, neutral, disagree, or when it comes to sentiment analysis in machine learning, you have positive, neutral, or negative sentiment of the, for example, post and discussion forum. Yeah. And then we have interval dimensions. This is very tricky because sometimes you have a numerical variable on the x-axis, but when you bin those variables to plot, for example, the histogram, the number of occurrences in a given bin, the name of the bin becomes a categorical variable, not a numerical variable. Okay, so Why do I say this to you? Firstly, because when you click the hyperlink here in my presentation, you will see the very useful decision tree which helps you to choose the best possible visualization to your data. And as you can see, it is the most important is this distinction between numerical, categorical, and numerical categorical variable. And for example, here we have one numerical variable, or few points or many points, which are not ordered or ordered. You have many different examples for a given histogram. You have an explanation for a given type of the plot, and even dedicated page showing you what for to use this tool type of visualization or not. Common mistakes, Mike. A lot of very, very useful insights. And also there is a data visualization handbook I provided you with as a hyperlink to the open source tutorial on how to visualize data from SAP, which is one of the largest, if not the largest provider of enterprise systems. And they have a great tutorial on visual perception from the psychological perspective. The most important for you, as you can see, numerical data and dimensions. Yes, you can see this example. I took it from this script, but what's the most important for you is here, selecting the right visualization. So we have different types of problems like change over time, comparison, ranking, part to whole, distribution, correlation, geographical information. And for each, you have the best possible ways to visualize data. For each, you have description, when it's used, the example, and some suggestions. Once again, the basis for this is just understanding the difference between categorical and numerical variables. So that was the first. I'm just simply a bit rushing up because I have only 3 minutes. I don't want to extend the lecture. And the second rationale for this distinction is here on my first PowerPoint. Yep. In machine learning, you can distinguish 3 types of problems in machine learning. At the moment, we have 2 extra, causal ML and generative AI, but let's keep it now simple. Classification is the prediction of the categorical variable. Forecasting or regression is the prediction of the numerical variable. Segmentation is just looking into the data, looking for patterns, yes? But the key takeaway for you is that whenever you have a categorical variable, that's going to be the classification problem with completely different set of algorithms and measures, quality measures. And whenever you predict the number numerical variable, that's a regression. Once again, a completely different algorithms, completely different measures, okay? And as you can see, I organized my examples around those 2 problems. Today we're covering the prediction of the numerical variable, so that's why I call this regression. On the next lecture, I will talk about classification, once again, a lot of different examples. And segmentation, we'll probably touch the segmentation example too on our next lecture.